Have you ever stopped to think about how an AI really knows if a sentence describes a picture? It seems simple, but it's actually a huge puzzle. Well, today, we're going to be the detectives on the case, figuring out how machines are learning to connect words and images. The investigation starts right now. All right, let's jump right in with our first piece of evidence. Take a look at this picture, and now this caption. A brown dog with white paws is trotting through a field of green grass. You and I, we spot the problem in a split second. That dog isn't brown. But how in the world does a computer catch that one tiny, incorrect detail when everything else is basically right? That's the mystery we're cracking today. So this whole thing has a name. It's called image-text matching. And it's way more than just a cool tech demo. This is a fundamental building block for AI that can actually, understand the world around us. We're talking about everything from way better image search to amazing tools that help the visually impaired see the world. Okay, so how did the first AI detectives even try to tackle this? Well, they started with a couple of basic techniques. You can think of this as the rough first draft of their investigation. So on one hand, you had global matching. This is kind of like a detective just glancing at the whole crime scene and getting the gist of it, looks like a dog in a field. Then, on the other hand, there was local matching. This is where the detective pulls out the magnifying glass and compares every little piece of evidence. This specific patch of fur to the word dog, this blade of grass to the word green. Super detailed. But these early methods, they had some pretty big problems. First off, they just give a simple score for a match, kind of like a thumbs up or a thumbs down. Not a lot of detail there. Second, they just averaged all the clues together, which meant a really important detail like the wrong dog color could just get totally lost in the mix. And finally, they got tripped up by totally useless words like on, or in, treating them like they were crucial clues. To fix all this, a new, way smarter detective had to show up. Researchers came up with this advanced method, one that was built from the ground up to avoid all those old mistakes. So let's meet the hero of our story, a method called SGRA. Now, SGSRA stands for Similarity Graph Reasoning and Attention Filtration. Yeah, it's a mouthful, I know, but don't worry about the name. All you need to know is that this system gives our AI detective two brand new, powerful skills to get the job done right. The real genius here comes down to these two new skills. First, you've got similarity graph reasoning, which is all about seeing how the clues connect to each other, not just looking at them one by one. And second, there's similarity attention filtration, which is all about learning what's important and what's just noise. Okay, so let's dig into that first skill. This is a real game changer because it completely changes how the investigation works. We're moving away from simple checklists and into something that looks a lot more like actual reasoning. Remember how the old systems worked? They'd look at a possible match and just give it a simple score. It was basically, yes, it's a match, or no, it's not. Super black and white with very little detail. The SGGraph method is totally different. Instead of that simple score, it generates what's called a vector-based representation for every single clue. So think of it less like a thumbs up and more like a detailed forensic report describing exactly how a bit of fur relates to the word dog, its texture, its context, where it is in the picture. We're talking a huge upgrade in detail. So what does it do with all these super detailed reports? Well, this is where the similarity graph reasoning module kicks in. It takes every single clue, the big picture idea, and all the little details, and builds a network connecting them all. It's literally creating a map of the evidence. The best way to picture this is to think of a detective's corkboard, with all the photos and notes pinned up. The real magic happens when the detective starts running string between the pins, connecting the dots. Suddenly, you see relationships you never noticed before. That's exactly what SGR is doing. It's a reasoning about how all the clues fit together to tell the one true story. And now for the second superpower, filtering out the noise. Because any good detective will tell you not all evidence is created equal. A lot of it is just distraction. So let's see how this AI learns to focus on what really matters. This is where the Similarity Attention Filtration, or SAF, module comes into play. Its whole job is to act like a filter. It tells the AI which connections are actually meaningful and important and which ones are just fluff. It learns to give more weight to the good stuff and suppress the irrelevant stuff. So let's take this sentence for example. An older AI would just try to match every single word to something in the picture. On, the. Talk about inefficient. But with SAF, AI is much smarter. It learns to focus its attention on the words that carry real meaning, the key players like dog, runs, grass, and fence. And at the same time, it learns to pretty much ignore those filler words, on, the, that don't add any critical visual information. It's literally learning to separate the signal from the noise. Okay, so you've got these two powerful new skills, connecting all the clues and then filtering out the noise. The big question is, does our AI detective actually solve the case any better? Let's check the evidence from the research. All right, so the researchers put SGREF to the test against the best method out there on a standard dataset called Flickr 30K. In a key test, the previous champion scored a 74.1% accuracy. The new SGREF method, it hit 77.8%. That's a 3.7 percentage point jump. Now, that might not sound like a huge number, but trust me, in the super competitive world of AI research, an improvement this big isn't just a small step forward. It is a massive leap. This is definitive proof that the new detectives' methods are just flat out better. And this quote from the researchers just nails why it works so well. The SGR part let the AI see how all the different clues were related, and the SAF part helped it focus only on the clues that actually mattered. It's that simple. By connecting the evidence and filtering out the noise, the AI came to a much, much more accurate conclusion. Which kind of brings us to a final really interesting thought. This isn't just about matching pictures and words anymore. This is about building an AI that can reason about relationships and filter out distractions to find the real meaning. So the big question is, if AI can start to grasp meaning on this deep of a level, what incredible things come next? What new capabilities are right around the corner?